So in this video, we're going to think about a different way that we could calculate delta H of reaction. And we're going to look at that in terms of something called Hess's law. So delta H reaction is specific for any given reaction. That means that every reaction should have a different delta H reaction. So we can measure that for many different reactions, and we can utilize these values to solve for an unknown reaction. So if we think about delta H reaction for the following reaction, A plus 2B goes to C, and delta H in this case is positive 12 kilojoules. So if a chemical reaction is multiplied or divided by a factor, then delta H is multiplied or divided by the same factor. So if we have 2A plus 4B goes to 2C, delta H reaction is 12 multiplied by 2, which gives you 24 kilojoules. So we could divide by 2, and so that would give us half of a mole of A, plus B gives you half a mole of C, and that would give you a delta H reaction of half of 12, which is 6. So we could do this by any factor. Typically, we'd use whole numbers, or maybe in some cases, rare cases, a half. And so the next thing we have to remember is that if a chemical reaction is reversed, then delta H changes sign. So if we know that 2A or A plus 2B goes to C, and that equals delta H, or delta H equals 12 kilojoules, if we go in the opposite direction, so C decomposes into A plus 2B, delta H is going to be the opposite sign. So in this case, it'll be negative 12 kilojoules. So when we think about this, we can just change the sign in any way, shape, form, or fashion. So this is going to allow us to manipulate delta H reactions in order to use them. So when we think about delta H, if a chemical reaction can be expressed as a sum of reactions, then delta H reactions is a sum of the delta H reaction values. So what does that mean? If we know that A plus 2B gives us C, and delta H1 is equal to plus 12 kilojoules, the plus is unnecessary, just present. And we also know that 2D goes to C, and this is delta H2, and that's going to give you plus 16 kilojoules. I would like to know what is delta H reaction for A plus 2B goes to 2D. And so we can use the equations provided, so we don't need to come up with those, and their provided delta H values in order to calculate delta H reaction for an unknown equation. So if we know that A plus 2B goes to C, we can flip the second equation where C goes to 2D. So the first one is delta H1, and that still equals plus 12 kilojoules. Delta H for this now equals negative delta H2, so that gives me negative 16 kilojoules. I'm going to slide this up a little, give myself some room. So now we can sum these up where we have A plus 2B plus C gives us C plus 2D. So the C's cancel out, and we get A plus 2B goes to 2D. So in that case, we would just also sum up these values. So delta H of this unknown reaction is going to be negative 4 kilojoules. So Hess's law essentially states that we can calculate delta H from a variety of other reactions. So the way we can think about this is we can utilize Hess's law to calculate delta H reaction, provided we have known reactions. So in this graphic, we have 4 different delta H values. If we would like to know this value here. We're interested in this reaction. So we can think about how to calculate that from the known reactions. So delta H4 is going to be equal to the sum of the other reactions. To make this a little bit easier, let's go ahead and give these values. So we know that delta H1 is going to be positive 2 kilojoules. Delta H3, and I'm just making these up, is going to be negative 8 kilojoules. And delta H2 is going to equal plus 3 kilojoules. Once we have this, you can likely, these are not to scale, start to think about, okay, we can think about if we know that delta H3 is equal to the sum of delta H1, 4, and 2 put together. So to calculate delta H4 is going to equal delta H1, so that would be 2 kilojoules. In this case, it's going to be plus delta H3, so it's going to be plus negative 8 kilojoules. And then it's also going to be equal to plus 3 kilojoules. So plus 3 kilojoules, so delta H4 is going to be equal to negative 5 kilojoules. And that makes sense because that arrow is going down where the energy is leaving the system. So this is a schematic example. So let's look at some other examples. So we want to calculate delta H reaction for 3 C solids plus 4 H2, and that gives us propane. So this is a formation reaction, which we'll see in the next video, but basically it says carbon solid plus hydrogen gas gives us propane. What is the heat of that reaction? So for a Hess's law problem, you have to be provided reactions. And so we have several reactions. So in this case, we are going to use these reactions in order to figure out this equation. So I'm going to label these 1, 2, and 3. This way, when I talk about them, you can look at them and see what they are. So oftentimes we ask ourselves, where should we begin? So you could pick any equation and look at that. And when we look at equation 1, which is propane plus oxygen decomposes into carbon dioxide and water. The only thing that is the same as the equation is propane, but propane's on the wrong side of the equation. So we're just going to flip number 1, and that's going to give us 3CO2 plus 4H2O, and that gives us C3H8 plus 5O2. Now delta H is going to equal negative delta H1. If this is delta H1, delta H2, and delta H3. So now we need to look at the second equation. We see a carbon solid, which is present in the top equation, but we need 3 of them. So we're going to multiply 2. We're going to multiply that by 3. So now I'm going to have 3 carbon plus 3 O2, and that's going to give me 3 CO2. So delta H equals 3 times delta H2. So from here, we need to look at the last one. So in this case, the hydrogen gas is the only thing we see present, and it's on the wrong side. So we're going to flip number 3 and multiply by 2. So we're going to flip it, and so that puts the reactants on the product side and vice versa. So we're going to 4H2 plus 2O2, and that's going to give us 4H2O. So delta H in this case is 2 times negative delta H3. So now we need to make sure that all of the things that are not present in the final equation cancel out. So I'm going to sum this up. So you'll notice that I tried to line up all of my equation arrows so we can have 3 CO2 plus 4H2O plus 3C plus I'm going to sum these 2 oxygens together. That'll give me 5O2 plus 4H2. That's going to give me C3H8 plus 5O2 plus 3CO2 plus 4H2O. So now we can cancel out anything we see on both sides. So we have 5O2, those both cancel. The 3CO2s cancel, the 4H2Os cancel. And what we're left with is 3 carbon plus 4H2, and that gives us propane, C3H8. So this is the equation that we're looking for, as you can see at the top. So now we can actually plug in our values here. And when we do that, we get that delta H equals negative 104.7 kilojoules. And based on this first value that only has, well, it has no decimal points, we need to round that to equal negative 105 kilojoules. Because this is, in fact, a addition question at the end. So with Hess's law, you'd be provided the equations of interest, and you can then convert to the known equation. So let's look at another example. So in this case, we want to calculate delta H reaction for N2O plus NO2, and that's going to give you 3NO. So we would like to know the balanced equation for that. So we're provided 3 different equations, 3 different delta H. I'm going to label these delta H1, delta H2, delta H3, and the same with my equations. So 1, 2, and 3. So now we need to know, how can we modify these? So the reality is, we're going to need to flip the first one and multiply through by 1/2. So this value right here, this 2N2O, is the only equation, or the only part of the upper equation. So that only needs to be 1. So we're going to flip 1 and multiply by 1/2. So I will get N2O, or NO2, goes to NO plus 1/2 mole of O2. So delta H is equal to negative 1/2 delta H1. So for number 2, we need to use that equation as is, because the NO is the only thing present in the equation, and we can see that here. It's also important to note that there is a nitrous oxide in the first equation, so we can likely total those up. So we're just going to use number 2 as is, to where we get N2 plus O2 gives us 2NO. So delta H equals delta H2. For the third one, we are going to have to use it as is, but multiply by 1/2. So 1/2 times number 3, and that's going to give me N2O plus N2 plus 1/2 mole of O2. So delta H is going to equal 1/2 delta 3. So then we're going to total these all up to where we have N2O plus N2 plus O2 plus NO2 gives us a total of 3NO plus N2 plus O2, because I totaled up the nitrous oxide and the oxygen gas. So our oxygens are going to cancel, our N2s are going to cancel, so we're going to be left with N2O plus NO2, and that gives us 3NO. From here, we can total up the delta H reactions, so that's going to give us delta H equals 157.6 kilojoules. So this is the reaction we were looking for, and we always want to double check, because sometimes you'll get equations that are not important, so you can't just add together the delta H values. For a Hess's law calculation, you would be always provided the extra equations. So to calculate delta H reaction for or using these values, and so they will always be provided.